Let a lies between 0 and 1 and S1 is a by 2. For all set o- for all real number we define Sn plus 1 equal to half of Sn square plus a. Then convergence of the sequence Sn is, so we have to tell about this sequence Sn is either convergent or divergent. If convergent, then you can easily find limit of this one. So there are many ways you can do. If anyhow you can find the limit of this sequence, then we can say this is convergent. So let this is convergent sequence and the limit of this sequence Sn is L. So as Sn plus 1, limit of Sn plus 1 will be L. Using this fact, we are finding limit. So limit as Sn plus 1 is equal to half of Sn square plus a, and taking limit to both sides, so limit of Sn plus 1 is equal to limit of, or you can take half outside because it is free from n, Sn square plus a. We have this L, half limit of Sn square plus a because of a is constant. So this is L equal to half L square plus a, and this one can be written as L equal to L square by 2 plus a by 2, or 2L equal to L square plus a. Now this is quadratic equation, means L square minus 2L plus a equal to 0, and using quadratic formula we can find roots of this equation. So L equal to 2 plus minus 4 minus 4a divided by 2, and there will be two root of this L, but limit is unique for convergent sequence, so we will decide further which limit will work for this sequence. So L equal to 1 plus minus square root of 1 minus a, this is L, but L is less than 1. Why? I am saying that somehow we have to check this sequence is increasing or decreasing, means we have to check that monotonicity of this sequence, then we can easily see that which L is work for this sequence. So check this, as it is given as A is lies between 0 and 1, so A square or A by 2, A by 2 is also lies between 0 and 1. This implies that S1 is lies between 0 and 1. So S1 is bounded, means first term is between 0 and 1. Similarly, if we take a square of S1, or this inequality, means S1 is square is less than 1, and this type, then 0 less than S1 is square by 2 less than equal to half, or S1 is lies between this. So take a square from this one. This should be half, and this should be 1 by 4. So it will be 1 by 8. Now it is perfect. So add a both side. Add a both side. So S1 by 2, and this is a square. So you can take a by 2 is less than equal to 1 upon 8 plus half. We added half both side. This implies that this, and also this one obviously greater than equal to 0. So this one is saying that S2, this is S2 less than equal to 5 upon 8, and this is greater than 0. So for other terms, similarly for other terms, we can say that Sn is bounded. Sn is a bounded sequence. But if a sequence is bounded, then we cannot say it is convergent because of this sequence minus 1 raised to the power n. It is bounded. 1 minus 1, 1 terms are these, but it is not bounded. So given sequence is bounded, and we check that either it is increasing or decreasing. So it is, as we can see, S2 S2 is half of S1 square plus A, and this one will be half A square by 4 plus A, because S1 is given, value of S1 is A by 2. So it can be written as A square by 8 plus A by 2, and this is greater than S1 because something is adding more. So S2 is greater than S1. Assume that it is true for K, means Sk plus 1 is greater than Sk, means we are applying mathematical induction here to prove this one. So we will prove for K plus 1. So Sk plus 1 is greater than Sk. Take square both side. S square K plus 1 will be greater than S square or Sk square. Now add A both side because A is positive. So inequality will remain same. Now take half or multiply because half is positive. So sign of inequality doesn't alter. This A is greater than half of Sk square plus A. Here we can say that this is Sk plus 2 greater than Sk plus 1. Means using mathematical induction we can see that it is true for all n or k, and k is comes from natural number. So this is increasing sequence, increasing and boundedness we proved earlier. So increasing and bounded, so it must be convergent sequence. So this is another way to prove that sequence is convergent. Now as sequence is increasing, so we can say that limit is positive because of all terms are positive. So why we chosen L equal to 1 plus square root of 1 minus a, you can see. Otherwise, because of 1 minus square root of 1 minus a, maybe because a is less than 1 and 0, a lies between 0 and 1. So if we choose, this is always positive and less than 1, less than 1, so 1 minus this may be positive. So this is not perfect reasoning. So how to say this limit is, how to say that this limit is this or this, as all terms, yes, all terms of the sequence, all terms of the sequence is bounded between 0 and 1. Sequence is bounded between 0 and 1, so limit cannot exceed, means limit will also lies between. So this is positive, this is positive value, so it cannot be limit. I said wrong, it cannot be limit, this is perfect reasoning. And 1 minus square root of this will be the limit because of this term is positive and 1 is added, so 1 plus something will be greater than 1, but all terms of the sequence lies between 0 and 1, so limit will also be lies between 0 and 1. So limit of this sequence is 1 minus square root of 1 minus a, and it is convergent.